All right, guys, back for another day. I thought we'd get a little bit more practice on working with these formulas like we did yesterday, as well as creating perfect square trinomials and factoring them before we get into reviewing completing the square. Okay, so again, not hard to do. Okay, remember, you take the first term and square the whole thing. So I have to square all of 5x. Bring the sign over for the middle term. Middle term is always 2 times the first term, 5x, times the second term, 3. And then it's always plus for the third term, second term squared. And then we just simplify. So when you square 5x, we get 25x squared minus, see, 2 times 5x is 10x, times 3 is 30x, so we'd have minus 30x, and then plus, obviously 3 squared is 9. Okay, let's see this guy again. Take the first term and square it, so x squared, bring the sign over. Middle term is always 2 times the first, x, times the second, 11, plus, always plus for the third term, second term squared. Okay, so let's see, that gives us x squared plus, well, 2x times 11 would be 22x plus 11 squared is 121. Okay, same thing here, take the first term, square it, take the x squared, bring the sign over for the middle term. Middle term is always 2 times the first term, which is just x, times the second term, which is 13, plus, always plus for the last term, second term squared, 13 squared, and then once again simplify. So let's see, we're going to get x squared minus 2 times x times 13, well, that'd be 26x, plus 13 squared is 169. Okay, let's see. Take the first term and square it. Remember, you got to square everything. Bring the sign over for the middle term. Middle term is 2 times the first term, which is 6x, times the second term, which is 5, plus, always plus, second term squared. And then simplify. Okay, when we square 6x, we're going to get 36x squared. Bring the plus over. Let's see, 2 times 6x times 5. Well, 2 times 5 is 10, times 6 is 60, so we get 60x. Plus 5 squared is 25. Okay. Notice these guys down here, we have 2 different variables in there. Doesn't make any difference. It's still the same exact process. So take the first term and square it, 2x. Bring the sign over, minus. Middle term is always 2 times the first, which is 2x, times the second, which is y, plus, always, third term is always plus, okay, plus y squared, and then simplify. So when we square 2x, we get 4x squared minus, let's see, 2 times 2x times y, well, that'd be 4 times xy, so just 4xy plus y squared is y squared. Okay. Same thing here. Take the first term and square it. A squared, bring the sign over, plus 2 times the first term, which is a, times the second term, which is 8b, plus second term squared. So we have to square the 8b. All right, so let's see. We're going to get a squared plus, okay, 2 times 8 is 16, so we'll get 16ab, plus, when we square 8b, we're going to get 64b squared. Okay, one more. All right, so let's see. We take the first term and square it, the 4a cubed, and we square that. Bring the sign down, plus 2 times the first term, which would be 4a cubed, times the second term, which is 7b to the fourth. Third term is always plus, square 7b to the fourth. Okay, now we just simplify. So let's see. 4 squared is 16. When we square a cubed, that's power of a power, so we multiply, so that'd be a to the 6th plus, let's see, 2 times 4 is 8, 8 times 7 is 56. Bring down the a cubed and the b to the 4th plus 7 squared is 49. And then when we square b to the 4th, that's power of a power, so we multiply, so that'd be b to the 8th. Okay, some more practice on that stuff. Obviously an important formula. All right, let's see. We were also doing some problems like this yesterday. Okay. All right, so let's see. We want to create a perfect square. We've got the quadratic term, we've got the linear term. I need the constant term. So my rule is take the coefficient of the linear term, divide by 2, so that'd be 18 over 2, and then square that. Okay, so I'm going to get x squared plus 18x plus, well, that would be 18 divided by 2 is 9, and 9 squared is 81. Okay, so that guy is a perfect square trinomial. Okay, and then if we want to factor it, okay, it factors into the square of a binomial. Okay, bring the sign of the middle term over, and then we take the square root of the first term. The square root of x squared is x, and the square root of 81 is 9. So that would be our factored form, okay, of the perfect square trinomial. And remember, if you're ever worried about it, just like we did yesterday in all of them, just take this and expand it, okay, and we should get this, which we will in this case. Okay, so same rule here. Take the coefficient of the linear term, 20, divide by 2, and then square that. Okay, so I have my x squared, I have my 20x, and then let's see, 20 divided by 2 is 10, 10 squared is 100. And I have a perfect square trinomial. Okay, I want to factor that. It factors into the square of a binomial. Bring the sign of the middle term over. Take the square root of the first term. Square root of x squared is x. Take the square root of the last term. Square root of 100 is 10. Okay, and that is my factored form of the perfect square trinomial. Again, if you use your formula to expand this, squaring x plus 10, you will get this perfect square trinomial. Okay, same thing here. Take the coefficient of the linear term, 4, divide by 2, and then square that. Okay, so we're going to have x squared minus 4x plus, well, 4 divided by 2 is 2, 2 squared is 4. And we have a perfect square trinomial. We want to factor that. It factors into the square of a binomial. Bring the sign over, so it's minus. Take the square root of the first term. Square root of x squared is x. Take the square root of the last term. Square root of 4 is 2. Okay, so that perfect square trinomial factors into the square of x minus 2. Once again, use your formula to expand that. You will get x squared minus 4x plus 4. Okay, 3 more to do. Take the linear coefficient, 2, divide it by 2, and then square that. Okay, so we're going to get x squared minus 2x plus, well, 2 divided by 2 is 1, 1 squared is 1. And that is a perfect square trinomial. Okay, it factors into the square of a binomial. Bring the sign over, so it's minus. Square root of the first term, square root of x squared is x. Square root of the last term, square root of 1 is 1. Okay, so that's our factored form of this perfect square trinomial. Okay. Okay, now notice all these linear coefficients are even, so when you divide by 2, things work evenly. Down here, they're odd, so it won't. Okay, so same process. Take the linear coefficient, 11, divide by 2, and square that. Okay, clearly 11 is not divisible by 2, so we're going to get a fraction there. So we get x squared plus 11x plus, when we square 11 over 2, you just square the numerator and square the denominator. So we're going to get 121 over 4. Okay, so that factors into the square of a binomial. Bring the sign of the middle term over. the square root of the first term. The square root of x squared is x. The square root of the third term. Well, this resulted from squaring 11 halves, so the square root of 121 over 4 is 11 halves. Okay, so that'd be x plus 11 halves squared. And this right here is the factored form of our perfect square trinomial. Okay, same thing here. Take the linear coefficient, 3, divide by 2, and then square that. Okay, so I have x squared minus 3x plus, again, when I square a fraction, just square the numerator and square the denominator. So I'm going to get 3 squared over 2 squared, which is 9/4. Okay, so that's my perfect square trinomial. It factors into the square of a binomial. Bring the sign of the middle term over. And then these guys are just the square roots of the first term and the third term. So the square root of x squared is x. Square root of 9/4. Well, 9/4 resulted from squaring 3 halves, so the square root of 9/4 is 3 halves. And we have our factored form. Okay, so a little bit more review. We did all this stuff yesterday. Okay, just wanted to do some more problems, give you another chance to work through some and get better at them. Okay, so now we get into solving a quadratic by completing a square. Okay, you did this in Algebra 1. I know some of you have had Algebra 2, some of you have not. I do not know if you saw this at all in Algebra 2. I'm not sure whatsoever. Okay, this should be review for all of you, but this usually is a topic where students don't always remember how to do this because they haven't done it in a while. Okay, so let's take this first guy. All right, now the first thing I want to do is set myself up so that it looks something like these problems. Okay, so I want to hold on to the quadratic term and the linear term, but I want to get this last term out of the way. I want to move it over to the other side. Okay, so this first one right here, I'm going to leave the x squared and the 8x where it's at. Okay, but I'm going to have to come up with that constant term to create a perfect square trinomial. So if I move the 9 to the other side, that's the same as just subtracting 9 from both sides. So the 9 moves over, becomes -9, right there. Okay, so I'm going to have to add a number here to the left-hand side to create a perfect square trinomial, which means if I add something to the left-hand side, I got to add something to the right-hand side, whatever that number is. Okay, so let's see. I take the linear coefficient, take half of that, and then square it. So I have to do the same thing over here. Take the linear coefficient, take half of that, and then square it. Okay, so I get x squared plus 8x plus, let's see, 8 divided by 2 is 4. 4 squared is 16. Okay, equals -9 plus, well, I already know that's 16. That's 16. Okay. So let's take this and factor it. Okay, so let's see. It factors into the square of a binomial. Bring the sign down to the middle term. Good. And then we take the square root of the first term and the square root of the last term to get these two terms in a binomial. So the square root of x squared is x. The square root of 16 is 4. Okay, and on the other side, we just add these two. -9 plus 16 is 7. Okay. Now notice we have a perfect square on the left-hand side, which means that I can take the square root. Okay, so if I take the square root of the left-hand side, that means I have to take the square root of the right-hand side. But remember, every number has 2 square roots, so that'd be plus or minus. Okay, so that means that x plus 4 has to be equal to either plus or minus radical 7. Okay, and so if I subtract 4 from both sides, I get x equals -4 plus or minus radical 7, which gives me my two solutions. One solution would be x equals -4 plus radical 7, and the other guy would be x equals -4 minus radical 7. So just like most quadratics, I get two solutions. Okay, we're in good shape there. Let's try this second one. Same process. Okay, so this second one. Okay, again, I want to keep this x squared and this x, but I want to take this constant term and move it over the other side and get it out of the way. So I have this x squared plus x plus, I'm going to have to figure out what that constant term is for it to be a perfect square. Now when I move the negative 20 over, it becomes positive. Okay, so I know I'm going to add something here to create a perfect square. So if I add something to the left side, I got to add it to the right side. Okay, so let's see. I want to figure out what is this guy. So I take the linear coefficient, which is 1, I divide by 2, and then I square that. So if I add 1/2 squared to the left-hand side, I got to add 1/2 squared to the right-hand side. Okay. All right, so this guy becomes x squared plus x plus 1/4. When you square 1/2, you get 1/4. Okay, so let's see, this will be 20 plus 1/4. Okay, so let's see, I got to factor this guy. It's a perfect square trinomial, so we know we have to factor it, okay, into the square of a binomial. Okay, I bring the plus sign down, okay, and I know this guy has to be the square root of the first term, so the square root of x squared is just x. And then this guy has to be the square root of 1/4. Well, 1/4 resulted from squaring 1/2, so the square root of 1/4 has to be 1/2. So this is x plus 1/2 squared equals. Now, obviously, when you add 20 and 1/4, you get 20 and 1/4. Okay, but of course, you know, I like my improper fractions, so I'm going to write it as an improper fractions. So 20 and 1/4 would be 81/4. Okay, and again, you can check that on your calculator if you need to. Okay, so now I'm going to take the square root of both sides. Take the square root of the left side, take square root of the right side. Remember, every positive number has 2 square roots. Okay, all right, so let's see. Square root of x plus 1/2 squared would just be x plus 1/2 equals plus or minus. Well, notice that 81/4 is a perfect square because the numerator is a perfect square and the denominator is a perfect square. So we just use our quotient rule. Take the square root of the numerator over the square root of the denominator. So this is plus or minus 9/2. Okay, so x is going to equal negative 1/2 plus or minus 9/2. And notice this guy, unlike the last one, doesn't have any radicals. So we can actually come up with these two numbers very easily. Okay, so let's see. X would be equal to negative 1/2 plus 9/2. Okay, that guy is equal to 8/2, which is 4. So one of our solutions is x equal 4. Okay, the other guy would be x equals negative 1/2 minus 9/2. Okay, so let's see, negative 1/2 minus 9/2, that's negative 10/2, which is equal to negative 5. Okay, so we get 2 rational solutions. Okay, so we're good there. Got those guys out of the way. Let's go down to the third one. Okay. Once again, same process. Okay, take this 50, move it to the other side so I can get rid of it. So we got x squared minus 15x plus, we got to figure out what's that number going to be, equals, the 50 moves over to the other side, becomes negative, plus whatever that number is. All right, so let's see. I have to take the 15, I have to divide it by 2, and then square that. So if I add that on the left-hand side, I have to do the exact same thing on the right-hand side. Okay, so I'm going to get x squared minus 15x plus. So let's see, if I square both of these, 15 squared is 225. Okay, 2 squared is 4. Okay, so negative 50 plus our 225 over 4. Okay, so let's see, this is a perfect square trinomial. Okay, so I have to factor that. So it factors into the square of a binomial. Bring the sign down. Minus. The square root of the first term, square root of x squared is x. Okay. Square root of 225 over 4. Well, that resulted from squaring 15 halves. So 15 halves is the square root of 225 over 4. So that's 15 halves. Equals. Okay, let's see. This guy right here, I'll do a little sidebar. Okay, so let's see. My little sidebar. Okay, just like I'm a lawyer. Okay, I have to write negative 50 as force. And so that's like negative 50 over 1. So notice I have to multiply above and below by 4. So when I do that, I get negative 200 over 4 plus 225 over 4. And so when I add the negative 200 and 225, I get 25. So I get 25 force. Okay. Take the square root of both sides. And again, we're taking the square root of a number, so each positive number has 2 square roots, so that's plus or minus. Okay, so let's see, we're going to get x minus 15 halves equals plus or minus. Again, 25 force is a perfect square. So you take the square root of the numerator and the square root of the denominator. Okay, so we're going to get plus or minus 5 halves. And notice, once again, we don't have any square roots here, so we're going to be able to come up with these two numbers because they're both rational. So I would have to add 15 halves to both sides. So x ends up being positive 15 halves plus or minus 5 halves. Okay. So let's see. X could be 15 halves plus 5 halves, which would give us 20 halves, which reduces down to 10. Okay, or x could be 15 halves minus 5 halves, which gives us 10 halves, which is 5. Okay, so again, there's our two solutions right there. Okay, all right, one more to do. Let's see what we got going on here. I like this guy. Okay, so just like the other guys, we want to hold on to the quadratic term and the linear term. We want to take this constant term and move it to the other side. Okay, so let's see. We have our x squared minus 3x. Okay, and I'm going to have to add some constant there to create a perfect square trinomial. When I take the negative 4 and move it over, it becomes positive. And whatever constant I have here, I have to add it over here as well. Okay, so let's see. Take the linear coefficient, divide by 2, and square that. So if I add that to the left-hand side, I got to add it to the right-hand side. Okay. All right, so let's see. This would be x squared minus 3x plus square the numerator and denominator. So I get 9 fourths equals 4 plus 9 fourths. Okay. All right, now this is a perfect square trinomial, so I'm going to factor it. Factors into the square of a binomial. Bring the sign down. Okay, square root of x squared is x. The square root of 9 fourths, well, 9 fourths resulted from squaring 3 halves, so the square root of 9 fourths is 3 halves. Okay, a little sidebar over here again. Once again, I should have gone to law school. Okay, that's like 4 over 1. So notice my common denominator would be 4, so I'd have to multiply above and below by 4 here. So that gives me 16 fourths plus 9 fourths. And 16 plus 9 is 25, so I'm going to get 25 fourths. Okay. Take the square root of both sides. And remember, anytime you take the square root of a positive number, you have 2 of them, so that's plus or minus. So we get x minus 3 halves equals plus or minus the square root of 25 fourths. So take the square root of the numerator and the square root of the denominator, and we get 5 halves. Okay, so adding 3 halves to both sides, I get x is equal to 3 halves plus or minus 5 halves. Okay, so that's where my two solutions come from. So let's see, x is 3/2 plus 5/2. That would give me 8/2, which is 4. So that's one of my solutions. Or, let's see, x could be 3/2 minus 5/2. So that would give me a negative 2/2, which is -1. And there's my other solution. Okay. All right, and again, this should all be review. I know you guys have seen it before. I also know that this is one of those topics where, you know, my students, when they come to me, they usually, most of them don't remember how to do it. So hopefully this will help you out. We'll do a little bit more of that tomorrow, and then we'll start moving on. You guys make sure you stay safe, and I miss you a whole bunch.